Yeah. So the next thing we are going to look at is a jump server, right? So this jump server, we can either call it as a jump server, we can also call it as your bastion host. Okay, so it's user defined. Generally, when we talk about your jump servers, you can also call them as your bastion host. Anyway, both are same. So we can either call them as jump servers, or we can call them as your bastion hosts, right? So what is the purpose of this? The purpose of this is to kind of give a common server. Using that common server, we can connect to a number of private servers, okay, private instances basically. All right. So a bastion host is a server whose purpose is to provide access to a private network. You can think of it as a VPN. All right. So let's say at an organization level, generally we have a VPN, right? Now, why do we need a VPN? So VPN is when you want to create a private network. If you want to connect to a private network, we make use of a VPN, right? So likewise, if you want to connect to any private servers, so generally at an organization level, what happens is we will be running all of our applications in the private servers. So let's say, for example, uh, let me log into my account. So at an organization level, the best practice that we have is we never deploy our applications in the public subnet. Okay, that is, we never deploy our applications in the public instances. Always we will have a private subnet, and our applications will be deployed in the private instances. However, because we have the private instances, we cannot connect directly to the private instances. We make use of a jump server. So this jump server acts as a common server, which can be used to access any number of private servers. So the practice is that we are not supposed to connect to the private server directly. We have a, you can think of it as a middleman. All right. So from our local machine, we will first connect to the jump server, and then from the jump server, we will connect to our private instances. Okay, that's the general practice that we have. So let's say, for example, here, let me call this as private instance. Okay, so let's say we'll go with the Amazon Linux AMI or Ubuntu. Anything is fine. That's up to you. And we will select our key pair over here. Let's say this one, and your network. So here we are going to use our custom network that we have created, and let's say we will launch this in the private subnet. Now, always when we talk about your private instances, we will never have a public IP address. You should never ever have a public IP address for a private instance. If you have a public IP to a private instance, it is no longer a private instance, it becomes a public instance. So always at an organization level, you will see that you make use of the private instances, which will not have any public IP associated with that. All right. So this will be your auto assigned public IP, and then your firewall. Now, for now, I will just select this existing firewall, but for the private instances, your security group will be slightly different. The rules will be slightly different. We will come to that. And then your storage, and then finally launch instance. This will launch an EC2 instance in my private subnet. So now here, if you will see, so here if you see, I don't have any public IP address. I have only the private IP address. So this means my instance is running in a private subnet. Questions until here?
No, sir.
All right. Now, how do you connect to this private instance? Now, obviously, we can make use of this private IP. So let's say, for example, here, let me try doing an SSH to this. SSH hyphen I, my PEM file, my username, and then the IP address. So what this will do is, this will try connecting to this server. Now, in this case, if you see, I'm not able to connect. All right, the connectivity to my private instance is not happening. So you see, this is loading basically, and after some time this will fail, telling that could not connect. Now, how do we do this? How do we connect to the private instances? Now, that's where we can make use of a dump server. All right. So a Bastion host is a server whose purpose is to provide access to a private network from an external network such as the internet. So now for this private instance that we have launched, we can create a jump server which will help me to connect to this private instance from the internet. So now here what is happening is from my local machine. So from my local machine we're trying to connect to the private instance over the internet, and it is not happening. So a Bastion host is also known as a jump server, and a Bastion host is a special purpose server instance that is designed to be the primary access point from the internet and acts as a proxy to your other EC2 instances. So this jump server that we will be connecting, that will be the primary access point for us using which we can connect to your private instances. So this is how the flow goes. What we will do is we will be having one instance which will be our Bastion instances, and then we can have any number of private instances. So from the local machine, we will first connect to this Bastion server, and then from this Bastion server, we can connect to any private instances that we have. Does the concept make sense? Any questions?
No, Ravi.
Okay. So now, for this to work, we will have to launch a public instance in the public subnet. So let's call this as jump server, and let's say Ubuntu and my key pair, and we will launch this in my custom VPC in the public subnet, which will have a public IP. We will select the firewall, and then we will launch. So now what we will have to do is from our local machine, we will have to first connect to this jump server, and from this jump server, we can connect to the private server. Okay, so that's how your flow works. So let's wait for the server to come up. And it is run. So now first what we will do is we will try connecting to this instance. So here we will first connect to the public server, the jump server. And now I am connected to the public server. All right. So here you can see this is 10.0.1.40, which is 10.0.1.40. So right now I'm in the public server. And from the public server, we will connect to the private server. So again, we will do this test underscore key.pem and then Ubuntu at the private IP address. Now, what do you think? Will this work or it will not work? What are your guesses?
Mm, I think it should work.
Okay, so let me try running this. And I get a permission denied error. Okay, so I'm basically not able to connect. So what do you think might be the problem here? Your problem is available in this log. So anywhere you can see the error.
Is it the key is not known by any other name? I mean, not specified
Which
any.
one? Sorry, sir, there's a disturbance on your end. I did not understand.
Is it the key it's not known by any other name? Is it the error occurring?
No. So it is giving you a permission denied error. That means there's a problem with the authentication. Okay. So now tell me any guesses. Again, your error is there somewhere here.
I mean, it is not able to recognize the PEM file, the key PEM file. That is the reason, I guess.
Yes.
Or the host cannot be established?
So the problem here is your PEM file. So here, if you see the first line, it is giving me a warning telling that the identity file that I'm trying to use is not accessible. So no such file or directory. So basically, now what is happening here is, so from my local machine, I connected to the public instance. So I had the PEM file on the local machine, and because of that, I was able to connect to the public instance. Now, from the public instance, I'm trying to connect to the private instance. So the PEM file, okay, it has to be available in this public instance. Only then I will be able to connect to this private instance, and that is what it is telling me. It is telling me that the PEM file that you're trying to refer, it is not available. Okay, and that's why I'm getting a permission denied error. So basically, the PEM file itself is not there, and it is not able to use that to connect to the server. Does that make sense?
Yeah.
Yes.
So there are different. So ideally, what you have to do is now you have to make that PEM file available on the server. So in our case, for now, what I will do is I'll manually copy this over to my. I'll copy this and I will create one file over here. So test underscore key dot pem, and this will be my private key. So begin RSA private key, end RSA private key, and I will save this. And now we will retry this command. Okay, now I'm getting a different error telling that unprotected private key file. Now this file that you see, this is a authentication file we have, right? So it's a very sensitive file, and there are too many permissions opened over here. So anyone can read this, and that's why I'm getting that warning telling that, hey, the file that you're using, it's very unprotected, right? So you can see permissions are too open. It is required that your private key files are not accessible by others. This private key file will be ignored because of bad permission. So we'll have to restrict the permission. So for that, we can use the chmod 400. Now what this will do is, so chmod is change modification. So changing these permissions can be done by making use of your chmod command. 400 is basically permissions. I will be, covering a bit of your Linux once we are done with the AWS. Before I start with DevOps, I will be covering a bit of Linux as well. So there I'll be talking more on this. Now, ideally, what this has done is this has reduced the permissions for me. So now you can see this is only read permission. So I had read, write, read, but now it is restricted. So this is what it is complaining me about. Now that I have fixed it, I can try connecting once again, and now you will see that I am connected to the private instance. So here, if you can see 10.0.2.7, which is my private instance. So now what we have done, from the local machine, we connected to the jump server. From the jump server, we have connected to the private instance. This is the concept of your jump server or bastion host. Questions?
No.
No, sir.
Okay. Now, this is something very commonly used at an organization level. You will see many projects or many companies using this as a very common practice to connect to the private instances. Now, the next thing we are going to talk about is your NAT gateway. Now, we already discussed about your internet gateway, right? So, can you tell me what is an internet gateway?
Give access to the flow,
Give access to.
I mean the subnets, and it will inside the direction it will give.
So internet gateway is used to give internet access to
Route
the
table and then
instances running in the public subnet. Okay, so at any point, if you want to give internet access to your instances which are running in the public subnet, we make use of your internet gateway. Likewise, if you want to give internet access to the instances running in the private subnet, we make use of your NAT gateway. That's the first difference or the main difference between your internet gateway and NAT gateway. It's a very common interview question, so please make sure you understand this and remember this. So first difference is internet gateway is used when you want to give internet access to the instances which are running in the public subnet. NAT gateway is used when you want to give internet access to the instances running in the private subnet. Does this make sense?
Yes.
So by default, your private instances will not have any internet access. For example, let's say I want to download something from the internet. So let's say I want to download Tomcat, Apache Tomcat. So let's go here and we'll go to, let's say, version 10, and I will go with this tar.gz. So I will copy this link and I will try doing a wget. Now, what is wget? Wget is a Linux command which can be used to download files from the internet. So if you say I'm giving this command, I'm giving the URL. So what will happen is this command will go to that URL and download this package for us. Now when I run this, by default, this will not work. So you can see it is trying to connect to that server. Whatever I've given over here, it is trying to connect to that server over HTTPS. This will not work because by default, your private instances do not have the internet access. So at any point, if you want to give you internet access to your private instances, we make use of your NAT gateway. So your NAT, it stands for network address translation. So this one, it simply stands for network address translation. That's the full form of it. They can use a network address translation or NAT gateway, as we commonly call it, to enable instances in a private subnet to connect to the internet or other AWS services, but prevent the internet from initiating a connection with those instances. So the second difference that you have between your internet gateway and the NAT gateway is that your internet gateway gives the internet access both the ways. That is, so let me put it here. So gives internet access to and from. Now, what does that mean? From the server to the internet and from the internet to the server. Now, let me show you an example for this. Okay, so you can see this is still trying because I don't have internet access. I'll cancel this. Let me exit from this private server. So when you do an exit, you will come back to the public server. So now I'm inside the public server. Now here, if I try the same command, you will see that it will work. So you can see here, I'm able to download it. So the file has been downloaded because we have the internet gateway for this. Okay, so remember we with the VPC that we created, we have created the internet gateway and we have attached it. Right? Do you remember that? Yes, no?
Yeah.
So this internet gateway, we created this and we have attached it to our VPC. And in the route tables, in the public route table, under routes, you see we are getting any traffic from this internet gateway and we are sending it to the public subnet. So because of that, this is working. Now, this is from the server to the internet. Now, likewise, from the internet to the server will be, let's say I will install my Apache server. So let's say HTTP, and I will set up a simple HTML page. Go to var .html. Yes, let me remove this. And so now, if I take the public IP, the public server that I have, and if I hit this, okay, so this is not working. So where will you troubleshoot this? Yes. Where will you start your troubleshooting?
You will start with the IP address.
So I have I have given the IP address here, and I'm not able to access that IP address. Now what will you do?
First, we need to check with the IP address is accessible to restart or not. We need to check with, or we need to check with the permissions. Is that IP address is accessible for us, and then only
Okay,
we
so
can
that
access.
okay, so that permission, where will you check it?
Uh, we need to check in the roles and permissions only.
Yeah, but where will you check that?
No idea about that.
Okay, so the first thing you will have to do is you will have to check your security groups.
Okay.
All right.
Security groups.
So yeah, so here this is a network issue, so you'll have to first start with your security groups. So if I go to the security group, you will see here. So what do I need to allow for this? Any idea? So I
Outbound
have to
rules.
allow HT. I have to no, I have to allow HTTP traffic for this. So this one. All right. So which is your port number 80. So I will have to allow that. So I will go to this security group and I'll add a new rule in my inbound traffic. So here we are going to allow HTTP, right? At an organization level, you will mostly see HTTPS, but for that you need a certificate. So uh, at an organization level, you will be using HTTPS. For our example, we are using HTTP. Now, if I refresh this, I should be able to access it. So now this is from the internet to the server. Okay, so that's basically this one. So from the server to the internet would be from here to the internet, and then from the internet to the server would be from here to the server. Does that make sense? Any questions?
Um, yes, Raghu. It is like whitelisting the IP.
Yeah, you can correlate it to that. So generally, we get requests like, can you please allow this specific IP address to access the server? So yeah, we are doing a whitelisting over here. So we are adding a rule over here to allow that particular IP address.
Okay.
Any other questions, anyone?
No, sir.
No.
All right. So that's your internet gateway. All right. So once again, internet gateway is used to give internet access to instances running in the public subnet. It gives you internet access to and from. So from the server to the internet and from the internet to the server. Whereas a NAT gateway, it gives you internet access to the instances which are running in the private subnet. And this give only one way internet access, which is from the server to the internet. Okay. This from the internet to the server will not work. Okay, so that's the other main difference about your NAT gateway. So, so that's what here I am telling. So, but prevent the internet from initiating a connection with those instances. So basically, even if I try hitting it from the internet, it will not work. So now, whatever we have done until here in your VPC, it is free. You don't have to pay any money for that. But with the NAT gateway, you will be charged. You'll have to pay money for this simply because it makes use of an IP address, elastic IP address. So you are charged for creating and using a NAT gateway in your account. To create a NAT gateway, you must specify the public subnet in which the NAT gateway should reside. You must also specify an elastic IP address to associate with the NAT gateway when you create it. So there are two main points that you'll have to remember when you're creating your NAT gateway. One, it makes use of your elastic IP address. Second, your NAT gateway should be created inside a public subnet. Okay, so these are two important points you'll have to remember. So after you have created a NAT gateway, you must update the route table associated with one or more of your private subnets to point in internet bound traffic to the NAT gateway. This enables instances in your private subnet to communicate with the internet. Now, each NAT gateway is created in a specific availability zone and implemented with redundancy in that zone. You have a limit on the number of NAT gateways that you can create in an availability zone. So here this will be the architecture. So your NAT gateway will reside in the public subnet, and then in your route table, you will be adding a route telling accept the traffic from this NAT gateway and send it to the private subnet. So let me show you this setup over here. So the first thing you'll have to do is create the NAT gateway. Again, keep in mind you'll have to pay money for this. So once you're done working with this, immediately delete it so that you don't get charged additional money. So we'll go to the NAT gateways and we'll create a NAT gateway. So let's call this as custom VPC NAT, and this should reside in a public subnet. Okay, so connectivity type you want public or private. So in our case, it's going to be public, and then the elastic IP. So we will need to create an elastic IP. So go with this allocate elastic IP, which will create an elastic IP for us, and then you can add a tag and click on create NAT gateway. That's your step one. Step two will be to add this in the route table. So remember, we have created two route tables, a public route table and a private route table. Internet gateway is for the public route table, NAT gateway is for the private route table. So we'll go to this private route table, we will go to routes, and we will edit this telling any traffic coming from the NAT gateway this time. Okay, which will be this one. Now, where I should send this? I want you to send this to the private subnet. So instances running the private subnet will get the internet access. Questions?
No, sir.
No.
Okay. So now,
Ravi,
yes,
I have
yes.
a question over here.
Yeah, yeah.
So you're using this NAT gate. Can we connect to the multiple instances at a time? Is it
Yeah,
possible?
yeah. So this NAT gateway is at a subnet level. Okay, so this is associated with the private subnet. So any instances which are running in this private subnet will get the internet access.
Okay.
We are not doing it at the instance level. We are doing it at the subnet level. So any instances which are running inside that subnet. So for example, here we are doing it at this subnet level. So any instances running inside this subnet will get that internet access.
Thanks, sir.
All right, so now let's go back and let me connect to the private instance once again. This will be my command. Okay, so now I'm inside the private subnet, private instance, and we will retry this command. And now you see it immediately downloaded it. And again, this is inside the private instance. And this is where your NAT gateway can be useful. However, now let's say we will install Apache 2. And let's go here. Now, if I try using this private IP, this will not work. Okay, so even if I try hitting this, even if you allow the rule, whatever you will do, it will not work. So your NAT gateway, it allows only one way internet access, which is from the server to the internet. Now, if that's the case, then how do we access the application running inside these private instances? That's where a load balancer comes in. We will be talking about that later on. This is your NAT gateway. Questions?
No, sir.
No,
All right. Now we also have something known as egress, only internet gateway. So this internet gateway that we have, it only supports your IPv4 traffic. Okay, so this one, it supports your IPv4 internet traffic. Now, if you want to use IPv6 internet traffic, we can make use of your egress only internet gateway, and this will be this will be IPv6, and this will also give internet access to your instances running in the public subnet, and this will be only from the server to the internet. Okay, it won't give you this internet to the server. It will be only from the server to the internet. However, this will be at the IPv6 level. So an egress-only internet gateway is a horizontally scaled, redundant, and highly available VPC component that allows outbound communication. So outbound would be from the server to the internet. Okay, so outbound communication or IPv6 from instances in your VPC to the internet, and present the internet from initiating IPv6 connection with the instances. So an egress-only internet gateway is for use with IPv6 traffic only. Okay, so here you have that option. So you can go to this egress only internet gateway and you can start creating this. Give the name, select the VPC and create this. And again, you'll have to add this in your route tables and then so on. But generally, we don't use this unless you're using IPv6. We don't work with this. Questions?
no. No.
All right. Then you have your DHCP options. Now, all these are some of the components of your network of your VPC. So DHCP stands for Dynamic Host Configuration Protocol, which provides a standard for passing configuration information to host on a TCP or IP network. You can configure DHCP option sets for your VPCs. The options field of a DHCP option contains configuration parameters, including the domain name server, and net BIOS type. So here again, this is something very commonly used with your DHCPs. All right. So if you want to set any domain name, for example, as of now, if you see the domain name, it says ec2.internal. So if you look at your instances, all right. So here, if you see this, it says ec2.internal. Now, if you want to use a different name, all right, you want to use like your own custom domain name, we can make use of your DHCP. So you can create a DHCP option set. You can give your domain name, like let's say, for example, ruby.com, right? So you can give that over here. And whenever you launch the instances, that domain name will be associated with your instances. So that's where we can make use of your DHCP, which is your dynamic host configuration protocol. Again, generally, we don't touch this unless you have a very specific use case. We don't touch it. The next thing we have is your elastic IP. So tell me who dropped. Okay. So tell me what are elastic IPs?
IP taught us in EC2, so whenever we stop the instance, so the public IP keeps changing. So to have a constant IP, we use elastic IP.
Yes. So the same we have in your 1 minute, sorry. Uh, yeah. So correct. That's basically what your elastic IPs are. So elastic IPs is whenever you want to have a static IP addresses for your instances, we can make use of elastic IPs. So the same thing we have here also in your VPC. So I'm not going to go over it, but that's what your elastic IPs are. So in this case, uh, if you see we have an elastic IP and we have associated this with a NAT gateway. Sorry. So as long as you're working with the NAT gateway, you'll have to pay money for this. Okay, this is not free. So be careful with this. So an elastic IP is a static IP for address assigned for dynamic cloud computing. We can use elastic IP in place of public IPs to have the same IP address irrespective of the state of the instance. So your NAT gateway is also using this elastic IP. So once you're done working with your NAT gateways, please go ahead and delete the NAT gateway. If not, you will continue getting charged for the elastic IPs as well. I'll delete this. And once the NAT gateway is deleted, make sure you're deleting the elastic IP as well. So, just to be on a safer side, you go and release this so that, so as of now, you can see this is associated. Okay, so that's association ID. So it is associated with your NAT gateway. So we'll have to wait for the NAT gateway to be deleted. But once the NAT gateway is deleted, you should be able to go and release the elastic IP as well. So this is still deleting. We'll have to wait for it. But yeah, I mean, that's what pretty much your elastic IPs are. So elastic IPs is whenever you want to have a static uh, public IP address, we can make use of your elastic IPs. Okay, so this is deleted. Now we'll go to the elastic IPs and we will release this so that we don't. Yeah, so you can see the association ID that's empty. So we'll release this so that we don't get charged for it. That's pretty much what your elastic IPs are. I'm not going to talk about this. The next thing that we will be looking at is your endpoints, but I think I will start off with that tomorrow because this will take some time to cover. Yeah, so tomorrow we should be able to. I'm hoping. Let's see. Yeah, I doubt. We'll see. Tomorrow I'm hoping to finish off your VPC, and once the VPC is completed, I will be giving you some assignments. Make sure you do that because again, like I said, this is a very important service that we have in AWS. Okay, so tomorrow we'll talk about your endpoints, VPC endpoints. We'll talk about your VPC peering and different concepts. All right, and Bharat said that from next week he would be available from Monday to Friday. So are you guys okay, Sedu and Prokshit? Are you guys okay from next week to have the classes from Monday to Friday?
I'm okay with any timings.
I'm okay with that.
Okay, cool. So from next week, starting Monday, we'll have this session from Monday to Friday. Right?
Okay.
Cool. Thanks, guys. I'll see you tomorrow then. Thanks a lot. Bye bye.